By the time we're seeing the fourth of these problems, I think it would be wise for us each to think about the idea of really trying to make this process more efficient. Starting the question with information, immediately writing our equation, quickly solving. So let's make it a goal in each of the subsequent questions to get faster and faster. I think that would be a good goal for both you and for me. So I'm going to try for each of these subsequent videos to really cut down the amount of talking, to really get straight to the point so that you can see how most mathematicians would solve these problems efficiently. Because that's the point of logs, is to be efficient. So in question number 4, let's start with the equation. We know what we're looking for. We need an initial value and a multiplier. So in January, that makes me already think they're starting initially in January. This guy has a balance of $2,500 on his credit card. For every month he fails to pay off his balance, the balance increases at a rate of 6% per month. This totally fits the mold that I saw before. $2,500 is what he begins with. There's our initial value. And the 6% must be related to his multiplier. Now it does say that the balance increases at a rate of 6%. So when I think about my percent multiplier structure, I always think about starting with 100%, but this time we're going to add 6% because it says increases. So 100% plus 6% is 106%. Move that decimal 1, 2 places to the left. That's a multiplier of 1.06 to the power of x. So this is looking good so far. We have the equation. Now I'll read the question part. How many months of non-payment will it take for this guy's balance to double? Now double is not a word that I would normally think of in this context, but balance doubling, now I can think about it. He has a balance of $2,500. If his balance doubles, that means we're looking at what happens when we're equal to 5,000 as a balance. So even though it didn't tell me that directly, it gave me enough information to realize what we're setting the equation equal to. We're setting the equation equal to whatever the question's asking about, and that means we're equaling it to the doubled value of 5,000. So here we go. First thing, get rid of anything that you can that's easily algebra accessible. So I'm going to divide the 2,500. Always get rid of whatever's clustering the multiplier, so that way you can focus on the logs separate. So 1.06 to the power of x equals 5,000 divided by 2,500 is 2. Now we can log both sides and we can do the exponential bit. So log of 1.06 equals log of 2. If I write, 1.06 power of x, my bad. By writing it with a log on both sides, that allows me to use the power property, and I can bring the x down in front. So x times log 1.06 equals log of 2. And now I can get rid of the log by dividing it. Since it's multiplying, I can just get rid of it by dividing it. Straightforward algebra there. Log of 1.06 divides to the other side. The logs on the left cancel out. X is by itself. That's what we want. And now it becomes a calculator problem. Now we have log of 2, close the parentheses, divided by log of 1.06, close those, 11.896. Always I write that number and then I go back and reread the question to make sure I understand the context in which that 11 makes sense. So I wrote 11.896, but I'm going to reread. How many months of non-payment will it take? Oh, it'll take 11.896 months. By now you've seen me check my answer in both the graphing calculator and by typing it in as more of a traditional calculation. So at this point I'm going to assume you have a way of checking your answers too, whether it's calculator based or just using the answer key, whatever suits you best. But notice now it's taking us less time to solve, and that's the goal. The more efficient you can get, the more repetitious these problems get, the easier it's going to be to realize that even though the problems have words, they're still the same problem over and over again. And as long as you can build an equation and use logs to solve it, you're going to keep seeing the same steps over and over, and you might not necessarily have to feel like these are as scary as they once seemed.